Hello, I wanted to give a few notes about the physical and chemical changes lab that you're going to be completing. There's a few things we do a little bit differently than how it's worded in the procedure. So I wanted to give you some notes ahead of time. So if you look at your procedure, look at step number 1. It says take a small piece of modeling clay and place it on a square of aluminum foil. And you'll be using that modeling clay to hold up a candle. We won't do that. We're going to just take our piece of aluminum foil, take our candle and our matches. What we'll do is strike the match, just very gently heat the bottom of the candle until you get about a drip of wax, and then just hold the candle upright and the candle will hold itself in place as the wax solidifies. Then what you can do is you can light the candle, hopefully with the same match. If you need another one, grab one. You should always extinguish these by using a beaker with some water in it. So it'd be helpful if you had that ahead of time. Then that way we don't light anything on fire when we throw them in the trash can. So it tells you to sort of record your observations. I know you've all seen a birthday candle burn before, but it's very important to watch this birthday candle, not from start to finish. You can move on to the other steps, but periodically look at the candle, don't blow it out, and watch what happens during the time that it's burning. Remember, this is all about physical and chemical changes, so you need to make observations which will indicate whether or not a physical or chemical change is taking place. So I'm going to move that to a safe place and we'll move on to step number 2. In step number 2 it says tear a small piece of paper into pieces and put them on a watch glass. You may recall that your watch glass is this curved or concave piece of glass. So we're going to take our paper and just make some small pieces here. And I like to crumple them up a little bit. Ultimately, you're going to set them on fire. So if you just lay them flat, it doesn't burn very well. So little pieces and sort of crumple them so that air can get around that paper, you'll get a much better result. If you just lay them all flat, then it will be very difficult to light. So you can grab your match again, ignite your paper, and again, you're watching the results that take place. So I don't want to give it away, so I'm going to move this out of range. Whatever you do, don't blow on your paper to blow it out. The paper and the ash will just sort of fly all over the place and possibly set things on fire. So definitely don't do that. The whole idea is not to get a raging fire going, but again to make observations of before and after of physical changes and chemical changes. So number 3, you need to grab out a test tube, and I would grab the whole rack because you never want to hold test tubes in your hand. Start off with a clean, dry test tube, and it mentions for you to half fill it with water. When it doesn't give you an exact number of milliliters, then you can just estimate about half full. Then it tells you to add a scoop of table salt, so you should have the table salt at your lab station. And again, we're being what we call qualitative here. And whatever you determine a small scoop to be, it says add it to your test tube, and then it tells you to put your thumb over the top and shake it, and that's to get the salt to dissolve, at least as much of the salt that's going to dissolve. It tells you in your experiment to make sure you record your observations. Again, we're looking for physical changes and chemical changes. Once you've done that, it tells you to use your dropper and add 5 drops of silver nitrate. Silver nitrate is stored in these bottles. They're wrapped with aluminum foil because silver nitrate reacts to light. So you don't want to leave it in a clear glass bottle, which is the only sort of droppers we had. So silver nitrate you'll find in this container, and when it says 5 drops, you just take out your dropper and add 5 drops and notice what happens in the test tube, if anything. Okay? For your next step, it says place a small piece of magnesium ribbon in a test tube. Students always make the mistake of adding it to that test tube. Don't. Either clean and dry that test tube or grab another clean test tube. Right? You want it empty. So magnesium ribbon is the element magnesium, but it comes in the shape of a ribbon. So I've cut it up already into these very small pieces here. So you can just take yours and either leave it flat or crumple it into a ball if you can and put it into your test tube. And then to that you need to drop, it says 5 drops of hydrochloric acid. Hydrochloric acid is also in a dropper bottle. Its abbreviation is HCl, and as its name indicates, hydrochloric acid is an acid. Acids are corrosive, which means they're harmful to soft tissues like your flesh, your eyes, your nose if you were to inhale it. So you want to be very careful with this stuff. It literally is acid. It's the same sort of acid that's used to dissolve the food in your stomach. So it can certainly be hazardous if you get it on yourself. That's why we have it in the dropper. So do as your directions say. When you're done with the dropper, just make sure it gets replaced back inside of your of the bottle so that it doesn't spill. Okay. Lastly, it tells you after you've done that to touch the bottom of the test tube with your fingertips. We normally don't do experiments in our hands like this. So you can either have it in your test tube rack or have it using your test tube clamp where you add the hydrochloric acid. When you go to test something with your fingertips, I would use the back of your hand because the back of your hand is way more sensitive to heat than your fingertips. So try it there and see if you notice a temperature difference. Okay, and that's what you're looking for, another observation potentially of a physical or a chemical change. Okay, I think I've covered everything. A few more reminders. Hydrochloric acid and silver nitrate are both dangerous, poisonous, so be careful with those elements. And make sure that when you're done, all of your materials have been cleaned up and put away. We will reuse the aluminum foil, so whatever's left of your candle, once that's extinguished, we can reuse the aluminum foil. Thanks a lot.